talk about last time?
Fermentation.
History.
Okay, so we talked about some history. What else?
Different types of microscopic organisms.
Okay, different types of microscopic organisms. So, we are going to, right now, fly through chapter 1 again, so stop me if you have questions on those, but just kind of so we can hit those highlights, make sure you guys are understanding them. So, talk about studying microbiology, talk about the early years, microscope, microbes, different types of microbes, prokaryotes, bacteria and archaea. What is a prokaryote?
They don't have any.
No nucleus. Very small.
Okay. Can I get a hand so I can get a concise answer that I can hear versus multiple? Sure.
Any type of microscopic organism which does not contain a nucleus tends to be much smaller, tends to have much less DNA than eukaryotes.
I would say yes, they're usually DNA. I'd have to check, but
Monomer
size.
bacteria tend to be the best example.
Size is really a big difference. Big difference between a prokaryote and what is the other one?
Eukaryote.
Eukaryotes. There's two basic types of cells. Prokaryotes, no membrane-bound organelles. They don't have a membrane-bound nucleus. We're going to talk a lot more about both of them today. Eukaryotes have that membrane-bound nucleus. So, fungi, protozoa, algae, those are all eukaryotes. Viruses, are they alive?
Some people say yes, some say no.
There are some who put them on the fence. They have a lot of the characteristics of it, but can't quite do it for themselves, so we tend to say no, they're not alive. And then also small multicellular animals. Okay, so again, sizes, spores. So we're looking at budding yeast. What was an example of budding yeast?
Saccharomyces cerevisiae.
Cerevisiae, Saccharomyces cerevisiae, yeah. Just because it's so common. But, well, we will actually even be looking at them today. So, pseudopodia, flagella, and cilia. What are these? What they have in common? Yes.
Modes of locomotion for the cell.
There you go. So, they're all modes of locomotion. Pseudopod, false foot, steps out, slides over. Flagellum, that big long whip that can help it kind of shoot through that media. Cilia, tons and tons of them that move in a wave-like motion. What are these?
Starts with the D.
Yes. Diatoms. Okay. So they're little single-cellular algae, the little glass, have the silicone shells. They're found in abrasive things like toothpaste and diatomaceous earth and porous, so very useful. What is a large multicellular example of these, or algae in general? Kelps. Okay. Parasites. Viruses. You can see just how small they are. We'll talk about them a little bit more later. So, we all feel pretty confident that we know that life did not arise from nothing. They have a bunch of different theories of how life started. Some really think it started in thermal vents. Some have this idea that, well, with all of the stuff, chemicals going around, maybe it was on hot rocks. So the ocean had a bunch of precursors to life, and by hitting the hot rocks, you evaporate water, so now it's a higher concentration, so they can kind of get together. But in general, life comes from other life. Okay, why were these swan necks so awesome in proving and just solving the problem of life coming from life? Yeah.
The way it's designed, it allowed air but prevented microscopic organisms from reaching the agar once it had been removed, once all other bacteria or microscopic organisms had been removed from it.
Okay, yes, so one thing, agar, usually we talk about, it's a solid, and it's kind of like Jell-O. So this is media, which is a liquid, because you can grow bacteria on that, but then you wouldn't be able to tilt them. It wouldn't move if it was agar. So yeah, the swan neck flask is great because it allowed air, so we know there's enough air, so microbes could grow if they were in there, you know, and then to prove that point, tilted the flask or broke it off and look, everything can grow. So it was very clean evidence that this is how it works. Okay. What is a hypothesis?
Educated guess.
Yes.
Proposed explanation for a set of observations.
Okay, so proposed explanation for a set of observations. So you observe something, you come up with, I think this is why, and then you do experiments. What's crucial to make your experiments valid?
Control.
Control. You always want to have control. You also want them to be yes/no questions, so that way you can either accept, reject, or you can slightly modify. You know, with the bacteria making alcohol, you reject that, but you can also kind of modify and go, but it makes acid instead of alcohol. Okay. Theories, long-standing hypothesis. Talked about all the different ones. Hand washing's important. What is Jenner known for immunology? What did he do?
Unethical experiments on kids.
Well, yes, but why do we try to look past that, and what did we learn from him?
Vaccines.
Vaccines. So he was the first one who got us to really think of vaccines and how can we do that. So, okay. Were there any other questions in that section?